Hello there, this is the beginning of Chapter 5, and throughout Chapter 5 we're going to be talking about linear functions. So the very first thing that we need to learn how to do is to identify whether a function is linear or not. So we have two vocab words, linear function, and a linear function is simply a function whose graph is a straight line, and a linear function is represented by a linear equation which can be written in the standard form ax plus by equals c. Now we learned in Chapter 4 about functions and how to identify functions, and remember that a function has to have every x value paired up with only one y value, and you'll need that information as we move our way through Chapter 5. So what we will be doing, and we're going to split this section up into two parts here, is determining whether a function is linear, and we're going to learn how to do it from its graph, from its equation, and from a list of ordered pairs. In this video we're just going to cover graphs and ordered pairs, and then in the next part 2 video we'll talk about how do we know from its equation whether a function is linear. So we'll start here with from its graph, and in order to determine if a function is linear from its graph, we just look at the graph and decide whether it forms a straight line. Okay? So all the points form a line, and that line is straight. And by straight, I don't mean like straight across or straight up and down. It can also be diagonal. It just can't have any curves in it. So let's look at some examples with graphs. Okay, now when we're doing this, you have to answer two questions, and the instructions above tell you those two questions. The first one is the graph a function at all? And if it is it a linear function? Okay, so if you'll remember from Chapter 4, to tell if a graph is a function, all we do is perform the vertical line test. And remember, with the vertical line test, it can only pass through your graph one time. And you can see here that it passes the vertical line test. So our first answer to the first question is yes, and we have to explain, so it passes the vertical line test. Okay, then the second question, is it linear? Well, does it form a straight line? And hopefully you can see that it does. Alright, so therefore yes. That says yes over here. Forms a straight line. So on your homework, you would draw the graph. That would be the original problem. And then you would answer the two questions just like I did here. So this would be essentially what your work would look like. Let's look at another one. Okay, so once again we have to answer the first question. Is it a function? So we do the vertical line test. As you can see, it passes. So we would say yes. Passes vertical line test. You notice I abbreviate a little bit here, and that's okay. Alright, and then is it linear? Yes, because once again this forms a straight line. Okay, and one last one here. So once again we start out with the vertical line test. And you'll notice this one fails the vertical line test. So in the answer to the first question, is it a function? No, because it fails the vertical line test. Now if it is not a function, then we don't even need to answer question number 2. Because if it's not a function at all, it's not going to be a linear function. Okay? So when it's not a function, then we don't have an answer to number 2, because number 1 answers the question. If it's not a function at all, then it's not going to be a linear function. Okay? And you could also have, yes, it's a function, no, it's not a linear function. That is an option. I know that I have yes, 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 and then just no. You could also have yes, no. Okay, that would also be an option. So that's how we tell if something is a linear function from its graph. Okay, so if we go back to our original slide here, from the graph, all the points form a straight line, and I should add in there, it passes the vertical line test. Okay, because it has to be a function before it can be a linear function. Now, let's look at ordered pairs. In order for a function to be linear, we have to have a constant change in x and a constant change in y. Now that sounds kind of confusing, but it's really not when we take a look at it. So in a linear function, a constant change in x corresponds with a constant change in y. So when we're given a set of ordered pairs, first thing we're going to do is we're going to put those ordered pairs into a table. And yes, you have to draw the tables. So I'm going to put x and y across from each other here, just like they're paired up in their ordered pairs. And then what we have to do is find our change in x. So notice this is plus 4. This is plus 4. This is plus 4. And this is plus 4. So notice that the change is the same all the way down. That's what we call a constant change in x. So then we have to check out y. Notice here plus 3, plus 3, plus 3, plus 3. So we also have a constant change in y. When we have a constant change in x and a constant change in y, it is a linear function. And we'd say constant change in x and y. Okay? Let's look at one more. So once again, we're going to take these ordered pairs, put them in a table. So from negative 4 to negative 2 is plus 2. From negative 2 to 0 is plus 2. 0 to 2 is plus 2. And 2 to 4 is plus 2. So then we're going to check the y values. 13 to 1 is minus 12. 1 to negative 3 is minus 4. Negative 3 to 1 is plus 4. And 1 to 13 is plus 12. Now notice here that these aren't constant, they change. So when they change, the answer is no. And we'll say y doesn't have a constant change. Okay? So that's how I'd show my work when I have ordered pairs. I'd put the ordered pairs into a table, check both x and y, and then say yes or no. Yes if they're both constant, no if they're not constant. Okay? So, as I said before, we are just going to do in this video graphs and ordered pairs. In the next video, we will talk about how do we tell if it's linear from its equation. So once again, if you have any questions, please make note of them in your notes so that you can ask them tomorrow. and I will see you then.